Tantor Audio, a division of Recorded Books, presents The Science of Star Trek, the scientific facts behind the voyages in space and time, by Mark Brake, narrated by Jon Vertullo. Introduction. If you want your children to be intelligent, read them fairy tales. If you want them to be very intelligent, read them more fairy tales. Albert Einstein. I don't think there is any world where Star Trek is anything but a progressive, liberal vision of the future in which big government is a good thing and we can all get along. It's a utopian ethos that is a result of one world government and not exceptionalism of any particular country. Mark A. Altman, The Washington Post, 2016. Star Trek was an attempt to say that humanity will reach maturity and wisdom on the day that it begins not just to tolerate, but take a special delight in differences in ideas and differences in life forms. If we cannot learn to actually enjoy those small differences, to take a positive delight in those small differences between our own kind here on this planet, then we do not deserve to go out into space and meet the diversity that is almost certainly out there. Gene Roddenberry, creator of Star Trek, the original series. Gospel for Outer Space. It's an honor to be alive, don't you think? To witness the grace, beauty, and complexity of the cosmos. A countryman of mine, the great but sometimes melodramatic actor Richard Burton, once said he wanted to end it all because of the beauty. Contemplating the sublime was simply too much for him. In contrast, Star Trek rejoices in that beauty. The Kirk-spoken title sequence of each episode in the original series suggests as much. Space, the final frontier. These are the voyages of the Starship Enterprise, its 5-year mission, to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. The introduction was, of course, changed for Star Trek The Next Generation to the more inclusive Where No One Has Gone Before and its continuing mission to reflect ongoing missions. First conceived by Gene Roddenberry as early as 1964, Star Trek has been a cult sensation ever since. Today, the franchise encompasses a broad range of offshoots, including novels, comics, figurines, games, and toys. Museum exhibits of the props from the franchise travel the globe. For the decade between 1998 and 2008, an attraction based on Star Trek played in Las Vegas. The constructed language of Klingon, spoken by the fictional Klingon race in the Star Trek universe, was created for the franchise and is actually spoken by some devotees. The franchise has generated between $10 to $20 billion in revenue, making Star Trek one of the highest-grossing media franchises in history. Not only is Star Trek recognized for its influence on the science and culture beyond science fiction, but it's also known for its progressive civil rights stances. The original series included one of television's first multiracial casts. From everyday science and tech to the quest to travel among the stars, Star Trek has impacted the way we think, the way we live, and the way we use tech on a daily basis. Lawrence Krauss's wonderful book, The Physics of Star Trek, was written way back in 1995. It's reasonably fair to say that Lawrence's book kickstarted the subgenre of science of books, which are now a popular feature of publishers' catalogs. And here I am, writing my 23rd science of book, which is partly about the 23rd century, among others. Like Lawrence, I am lucky enough to be in the generation that first witnessed the appearance of Star Trek on our television screens in the 1960s. I must admit, I've never attended a Comic-Con decked out as a member of the Borg, but I have, nevertheless, had a long and wide experience of the franchise over the last 6 decades or so. In that time, Star Trek has not only helped us imagine the science and cultures of future human societies, but it has also helped us imagine what those societies themselves might look like. So, in this book, you will find chapters not only on the related science and tech of Star Trek, but also the more social science side of the franchise. Star Trek is, of course, science fiction. And all science fiction can be thought of as being about the culture shock of discovering our marginal position in an alien universe, as revealed by the advance of science. Star Trek is an attempt to put the stamp of humanity back on the universe, to boldly go. Furthermore, science fiction, like Star Trek, is concerned with the relationship between the human and the non-human. On the surface, Star Trek seems to have a bewildering number of themes: aliens and time machines, spaceships and cyborgs, utopias and dystopias, androids and alternate histories. But on a more thoughtful level, we can identify 4 main themes: space, time, machine, and monster. Each of these themes is a way of exploring the relationship between the human and the non-human. Studying these themes will enable a clearer understanding of the ways in which Star Trek works, and what the franchise has to say about science and society. Space. The space theme sees the non-human as some aspect of the natural world, such as vast interstellar spaces in which the Federation travels, or the alien, which can be seen as an animated version of nature. Here, we discuss topics such as space travel, the science of exoplanets, and why we even call them space ships in the first place. Time. The time theme portrays a flux in the human condition brought about by processes revealed in time. Tales on time often focus on the dialectic of natural history, so they are of particular relevance to evolution and biology. We examine the ways Star Trek deals with topics such as alternate histories, how to leave footprints in time, and the history of Star Trek itself. Machine. The machine theme deals with the man versus machine motif, including robots, computers, and artificial intelligences. Dystopian tales are part of the man versus machine theme. It is the social machine in which the human confronts the non-human in such cases. This part has entries on Star Trek's machine motif, including machine slavery, the Dyson sphere, and the replicator. Monster. In monster tales, there is often an agency of change, such as the cosmic evolution in The Chase, which leads to the development of different humanoid aliens. We also discuss the monstrous nature of war, in which humans become more bestial, and how the political use of tech may mean modern humans are becoming more Borg. Naturally, many of the scientific wonders of the Star Trek universe sit at odds with our current conceptual understanding of the cosmos. But the point of this book is not to take Star Trek tales scientifically literally. Star Trek is science fiction, after all. Nor will you find here an obsession with the mere inventions alone, a kind of commodity fetishism about the guns, gadgets, and transporters that litter the franchise. They are mere decoration. No, this book addresses the bigger picture. This book takes the long view, the larger-than-life scientific and cultural contexts which act as world-shaking scenarios to the Star Trek universe. Live long and prosper. Part 1. Space. What can Star Trek tell us about aliens in our Milky Way? Almost certainly, there is enough land in the sky to give every member of the human species back to the first ape man his own private, world-sized heaven, or hell. How many of those potential heavens and hells are now inhabited, and by what manner of creatures, we have no way of guessing. The very nearest is 1,000,000 times farther away than Mars or Venus, those still remote goals of the next generation. But the barriers of distance are crumbling. One day, we shall meet our equals, or our masters, among the stars. Arthur C. Clarke, 2001, A Space Odyssey, 1968. Galaxies. Space. The final frontier. The USS Enterprise embarks on a 5-year mission to explore the galaxy. Like island universes, galaxies are swarms of suns, adrift in the ocean of space-time, each a vast collection of stars, dust, gases, and matter. A galaxy is bound by gravity, and collectively, galaxies are the cells that make up the large-scale structure of the cosmic body of the universe. Natural events in galactic dynamics occupy tens of millions of years, and yet our modern notion of a galaxy is barely 100 years old. On April 26, 1920, at the Smithsonian Museum of Natural History, astronomy's great debate took place. At stake was the human measure of the very scale of the universe itself. During the debate, one astronomer, Harlow Shapley, argued that our Milky Way galaxy was the entirety of the universe. His opponent, Heber Curtis, contended that the Great Spiral Nebula in Andromeda and other such nebulae were, in fact, separate galaxies, or island universes, a term originally coined by 18th century German philosopher Immanuel Kant, who was one of the very first to believe that the spiral nebulae were extragalactic. It wasn't until later in the 1920s that a perhaps more famous American astronomer, Edwin Hubble, showed that many nebulae, thought to be clouds of dust and gas or single stars in formation, were in fact galaxies beyond our Milky Way. For many years, the number of galaxies in the observable universe was thought to be around 200 billion. But in October 2016, the New York Times reported that astronomers now estimate the cosmic galaxy number at 2 trillion. At the very least, Star Trek Picard fact-checks this new galaxy number in Episode 4, Absolute Candor, when Dr. Agnes Girardi muses over the nature of space. There are a septillion known planets, so maybe space should be called vast quantities of stuff. The sheer scale of the cosmos is terrifying for some. It certainly worried Victorian poet Alfred Tennyson, even though little was then known about modern cosmology. In 1855, Tennyson wrote his poem, Vastness, in which he declared, "This poor earth's pale history runs. What is it all but a trouble of ants in the gleam of 1,000,000,000,000 of suns?" The population of the Milky Way doesn't quite reach the heady heights of Tennyson's 1,000,000,000 suns. The old British billion of a million has since lost its battle with the American billion of a mere 1,000 million. The Milky Way, in which our sun sits, is thought to contain between 100 and 400 billion suns, and more than 100 billion planets. Rather than being troubled, like Tennyson, by this vastness, Star Trek's unremitting missionaries explore these strange new worlds, aiming to seek out new life and new civilizations. Star Trek, a crowded galaxy. In the Star Trek universe, the Milky Way is replete with alien life, of course. The galaxy is divided into 4 quadrants: Alpha, Beta, Gamma, and Delta, the first 4 letters of the Greek alphabet. Each quadrant roughly comprises 1/4 of the Star Trek galaxy, and each quadrant is divided into thousands of sectors. As we well know, the 4 great powers in the Alpha Quadrant are the United Federation of Planets, the Cardassian Union, the Klingon Empire, and the Romulan Star Empire, though admittedly these last 2 imperial powers hold most of their territory in the Beta Quadrant. The galactic core is the intersection of all four quadrants. Real astronomers also divide our galaxy into quadrants. What's the main difference between the real and fictional quadrant systems? The galactic quadrants in astronomy are based around a perpendicular axis that runs through the sun, while the Star Trek system is far less geocentric. It's based around an axis that runs through the galactic center. In short, Star Trek is less parochial and more progressive. Watching Star Trek makes us wonder something quite profound. If our Milky Way was anything like the Star Trek galaxy, might it be possible, if our galaxy also teems with spacefaring civilizations, to have isolated and unvisited worlds like ours? Could it be that Earth simply remains, as yet, undiscovered by alien intelligence? The encouraging scientific answer to this question is a resounding yes. Here's a summary of what we are about to argue. Scientific projections suggest that if there are alien planet-hopping species in the galaxy, they could spread across the Milky Way quite swiftly, cosmically speaking. Why have we found no undeniable evidence of extraterrestrial visits to Earth? Because galactic settlement happens in waves, and humanity has arisen on a relatively obscure planet during a local lull in galactic exploration. Sea of water, sea of space. Before we look in more detail at the galaxy's sea of space, consider the case for our earthly seas of water and the story of HMS Bounty. Launched in 1784, the Bounty was a small merchant vessel that the British Royal Navy bought for a botanical mission. Rather famously, the Bounty was sent to the Pacific Ocean under the command of Captain William Bligh, but the mission was never completed. A mutiny led by Acting Lieutenant Fletcher Christian seized control of the ship from Bligh, and the mutineers settled on local islands. Some listeners may recall movie portrayals of the mutiny of the Bounty where Christian is played by Marlon Brando, 1962, and Mel Gibson, 1984. In Star Trek IV, The Voyage Home, HMS Bounty is roughly painted in large red letters along the side of the bird of prey, with Kirk writing in his log, "Like those mutineers of 500 years ago, we too have a hard choice to make." In January 1790, 9 mutineers from the Bounty, along with 18 Tahitians and a small child, set foot on Pitcairn Island, one of the most remote but habitable places on the planet. Adrift in the South Pacific Ocean with hundreds of miles of sea to neighboring islands, Pitcairn is its own island universe. The mutineer group were the first people Pitcairn had seen in some time. The island had not had human occupation since the 15th century, having been previously inhabited by Polynesians until the ecology became simply unsustainable. But here's the thing. After the arrival of the Bounty Party in 1790, it was almost another generation before any other ship dropped anchor at Pitcairn Island. Though the Bounty settlers saw ships sailing past in the distance, no one else set foot on land. It might come as a surprise to some listeners to learn that New Zealand was one of the last major landmasses settled by humans. Various techniques including radiocarbon dating, deforestation evidence, and mitochondrial DNA nuance in local Maori populations suggest that New Zealand was first settled by Eastern Polynesians as late as 1300 AD. That's really something when you consider the fact that archaeologists and population geneticists believe indigenous Australians inhabited the Australian continent for perhaps as many as 65,000 years prior to European discovery. To give a measure of how close the two landmasses are, during the Australian bushfires of late 2019 and early 2020, the skies over New Zealand turned at times orange and other times dark and gloomy from the residual smoke. Such are the unusual dynamics of human occupation. Easter Island, Rapa Nui, is the most remote inhabited island. It took humans almost all of history to get there. The Polynesians were the supreme open ocean goers in world history, and their skill at navigation using double-hulled canoes over vast expanses of sea is one of human history's greatest triumphs. They settled New Zealand, Hawaii, and many other islands in the remote Pacific. The tales of Pitcairn and New Zealand are far from unique. Across the South Pacific are thousands of islands essentially lost in the millions of square miles of sea. Many of these islands may be mere rock and coral, of course. Others, like Pitcairn, may boast habitable ecologies but no human inhabitants. But, like the stars across interstellar space, these islands are constellations of potential settlement for those motivated enough to navigate the space between. And so to the stars. How does this example of Earth's South Pacific apply to the Star Trek galaxy and our actual Milky Way? The parallels are striking. As we said earlier, the estimate of the number of stars in our galaxy puts the stellar population at as many as 400 billion suns. And the latest estimates from NASA's exoplanet hunters suggest the galaxy harbors more than 10 billion habitable rocky worlds within the seas of the Milky Way. Like the islands that speckle Earth's oceans, these exoplanets are possible living way stations. They could provide a series of stepping stones for any species with the outward urge to migrate across galactic space. This comparison is pretty crucial to our argument. Europeans finally discovered that Polynesians had spread across thousands of miles of the southern Pacific on simple watercraft, happily sailing along at just a few knots. Similarly, galactic migration could be carried out with relatively simple spacecraft and, naturally, sufficient oodles of cosmic time. When we look back at the Apollo missions from the relatively technologically sophisticated 21st century, we are often amazed by the crude and simple spacecrafts that first took astronauts out to the moon. Fermi's paradox. This simple state of affairs also provides a new answer to Fermi's so-called paradox. As legend would have it, in response to the question of extraterrestrial intelligences, Nobel Prize-winning Italian physicist Enrico Fermi said over lunch with colleagues in 1950, "But where is everybody?" Where indeed were all the spacefaring species that, according to most science fiction, were meant to be clogging up the cosmos? Fermi's point was this: unless alien life was rare, an argument that biologists sometimes make, tech-savvy extraterrestrials should have spread through the galaxy. And yet, we see no credible evidence, save the odd story of greys creeping up behind stoned hippies at rock festivals. Fermi was known for his quick wit. He'd won a Nobel Prize, after all. And over lunch, and in one quip, he seemed to have figured out that migration into the Milky Way could be done in an instant, as long as that instant was a few million years. Ever since 1950, physicists have been refining their interpretations of Fermi's paradox. Take, for example, the fact of the continuing absence of aliens on our planet. This absence leads some scientists to conclude that there are no other technological civilizations in our galaxy. Nor, indeed, they suggest boldly, have there ever been. It seems that the crucial factor in this glum scenario is the assumption that it would take a relatively short amount of time for an extraterrestrial species to migrate across the Milky Way's 100,000 light-year span, even if, as the argument goes, the alien spacecraft was propelled along at plodding sublight speed. According to associated calculations, in a few million years, those aliens possessed with an outward urge could have visited every last nook and cranny of the local galactic cosmos. As our solar system has been here for almost 5 billion years, and latest estimates put the age of the Milky Way at around 10 billion years, there has been plenty of time for those tech-savvy extraterrestrial species to visit all habitable planets. Freestyling Fermi. In most of these refinements to Fermi's lunchtime quip, there's a pretty constant scenario, and it goes something like this. Stars and their planets become inhabited, assuming they weren't so already, then act as the next stage stepping stone for further onward migration to new systems. And yet, the scenarios always seem to assume the same thing about the scope of the tech used for galactic travel, and that sentient beings can actually survive the journey. What do we know today about these scenarios for interstellar travel? Well, for one thing, the scientific consensus is that even traveling at a modest 10% of light speed will need some pretty nifty tech, such as fusion bomb propulsion, gargantuan laser-driven light sails, and spacecraft designed to protect ships from high-speed effects. Design features include shielding of the hull from the constant attrition of interstellar gas atom impacts and starship-smashing rock debris, which packs the punch of a bomb at any reasonable fraction of light speed. Naturally, slower speeds are safer, but come with interstellar journey times of centuries or millennia, as we have yet to learn how to keep a ship's crew alive for such time spans. There are other takes on Fermi's paradox, of course. A fascinating one is the idea that, unlike humans, alien civilizations have no interest in reaching other stars. No outward urge. No sense of curiosity, weirdly. None of them. You can understand that, based on this premise, the whole mission of Milky Way migration melts away from the get-go. For Star Trek fans who are well aware of the possibilities of the rich variety of life in our galaxy and beyond, it's easy to conclude that this stay-at-home interpretation of Fermi is something of a monocultural mistake. Heavens, we can't even get the different branches of Homo sapiens to agree on a number of matters. Besides, even if most aliens were against dipping their toes in galactic waters, all it would take is a single curious species to take the plunge and spread their seed across the light years of the Milky Way. Indeed, the historical debate on Fermi is rich in alternate hypotheses. One solution is based on the simple matter of the cost of space travel. It may be that the expense of reaching the stars and maintaining that interstellar reach across space is simply too high, even for a technologically advanced species who have carefully planned their conquest of space from the start. Or it may be that population growth does not motivate a species to take to the stars. This last solution would be especially true, perhaps, for an extraterrestrial race that rationally plans ahead, developing a sustainable ecology on its home planet. Why travel when the other alien's grass isn't necessarily greener, or whatever color alien grass might be, assuming they actually had grass, of course? Thinking about this, would the hopefully imminent green revolution on Earth result in the cancellation of human space programs? The revolution might mean space exploration has no point other than scientific curiosity, which might prove tricky as many venture capitalists are merely looking for some kind of bang-for-their-buck bonanza. Then there's the Great Barrier, the notion that there are factors that limit alien conquests of space. Maybe it could be a failure to reach that green revolution, with rampant industrialization leading to an entropic and pollutive decay of the planet and all technological progress. Of course, there are plenty of natural barriers, too. It's hard to explore space when you're hampered by natural catastrophes such as supernovae or the terrible and creeping advance of a nearby black hole, which coldly eliminates some potential spacefarers from galactic life. Listeners may recall Star Trek The Next Generation's episode, The Inner Light. It features a civilization on the non-Federation planet of Catan, whose exploration of space was terminated by their sun going nova, exterminating all life in their system. And yet, one feels these extreme examples are the exception that proves the rule. It would be remiss of me not to mention here what's sometimes called the zoo hypothesis. According to this rather fringe and somewhat science-fictional theory, humans are being kept in the dark by alien powers. We remain isolated because that's the way E.T. wants it. It's an extension of the usual political terrain.
Sample complete. Ready to continue?